All right, in this video, we're going to finish up section 4.2. Here, we're going to find the actual area or the approximate area under a curve. So, if I happen to have a graph with some curve on it, and I want to know the area between x equals a and x equals b, between my x-axis and my curve, then I'm asking about the area in here. Well, if this doesn't have any straight lines to it, it is very difficult to find, so we're going to do it by approximating. So what we're going to do is we're not going to use this. We're going to create rectangles. So if I break this up into rectangles, if I can find the area of each rectangle, I can find the area. Well, this is done in three primary ways. One of them is called the lower sum. So when I say lower sum, that means I want to take the lower end of each rectangle. So for rectangle 1 here, I want to take my shorter side, or the side that does not go as high, draw a horizontal line and top it off. So this is my first rectangle. For rectangle 2, I want my lower side, top it off. This is my second rectangle. For rectangle 3, this is my lower side, top it off. This is my third rectangle. And for rectangle 4, they look about even, so top it off right there and go down. I can then find the area of each one of those 4 rectangles and add them up to get the area, the approximate area under the curve. Well, the other way to do this is by using upper sums. And upper is the reverse of lower. So instead of using the lower end of the rectangle, now I want to use the higher end or the upper end. So for rectangle number 1, I want to do my higher end now. Cut it off and go all the way down. That is now rectangle 1. For rectangle 2, where my higher or taller end hits my function, draw a horizontal line to top it off. For rectangle 3, where my higher end hits my function, horizontal line to top it off. And then the same thing for rectangle 4. So you can see my upper sum triangles have too much information. It's going to be too high for my approximate area. And my lower sum is not going to have enough information, so it's going to be too low for my actual area. So my actual area will fall somewhere between the two. So let's go ahead and do a problem with these. All right, so we are going to find the upper, lower, and mid sums for the function f of x equals x squared on the interval from 1 to 5. All right, so the first thing I suggest you do every time on this is to draw it out. Hopefully we're all aware of what x squared looks like. So x squared is a parabola that goes up. But I'm only caring about what happens from 1 to 5. So 1, 2, 3, 4, 5. So I want this area between 1 and 5 right there. We are going to use 4 rectangles. So I'm going to draw a line for everything we're going to be doing on the next test. And here, everything is going to have a uniform width of 1. So there's 1, there's 1, there's 1. So you can see rectangle 1, 2, 3, and 4. All right, so now for my upper sum. So my upper sum is going to be the area of rectangle 1 plus the area of rectangle 2 plus the area of rectangle 3 plus the area of rectangle 4. All right, well, how do we find the area of a rectangle? It is base times height or length times width, whichever way you like to think of it. Well, what's nice in all of these is that my base or my width is 1. So it's 1 times something for all of these. I'm running out of space. And what is my something? My something is my height. So I have to find the correct height. Well, for this graph, we are doing the upper sum. That's what I asked for. So that means I'm going to take my taller side. The upper sum is always the taller side. So for rectangle 1, I want this rectangle, too much information. For rectangle 2, that rectangle. For rectangle 3, that rectangle. And for rectangle 4, this rectangle. So I want too much information. All right, well, you can see on the right-hand side of each rectangle, it hits my actual function. So that y value is my height. Well, for rectangle number 1, I hit my y value right here. That's when x is actually 2. So this is an x value of 1, 2, 3, 4, 5. So this is going to be f of 2 because that's my height right here. For rectangle 2, I want my height. I want to know this value. Well, that's my y value when I plug in 3. So this is going to be f of 3. For rectangle 3, I want to know my height. That's going to be all the way up here. So that's going to be f of 4. Plug in 4 for my x value. I'm going to get out my height. And for rectangle 4, I'm going to plug in this 5 value right here. That's going to be my x value to plug in to get my y value up there. So it's going to be f of 5. All right, well, remember from above, my function is f of x equals x squared. So my upper sum is going to be 1 times 2 squared, that's what I'm plugging in, plus 1 times 3 squared, that's what I'm plugging in, plus 1 times 4 squared, that's what I'm plugging in, and then 1 plus 5 squared. So I can figure that out fairly quickly. 1 times anything is itself, so my upper sum is going to be 2 squared, which is 4, plus 3 squared, which is 9, plus 4 squared, which is 16, plus 5 squared, which is 25. When I add all of this up, I get my upper sum to be 54. All right, let's see if we can do the lower sum now. All right, so we're going to draw the same picture. So for my lower sum, I highly recommend each time you draw the picture. So again, it's going to be y equals x squared, which is still a parabola. 2, 3, 4, 5. So I still want to know between x equals 1 and x equals 5. But now I want to know my lower sums. So now I want to know not enough information. It's going to be smaller than my actual area. So what I'm going to do is where my shorter side hits. So for this is 1, this is 5. So my shorter side hits here and bring it down. And then for rectangle 2, where my shorter side hits, down and over. Rectangle 3, where my shorter side hits. Rectangle 4, where my shorter side hits. So you can see for between 1 and 5, I picked where my shorter side now hits my function. That's how I'm going to get my lower sum. So now I need to add all of that up. So my lower sum is still going to be my base times my height. So my base on all of these is still 1. And then it's going to be f of 1 this time because I'm taking the left-hand side. That's the shorter side for rectangle 1. Plus 1 times now f of 2 for rectangle 2 because I want the shorter side. Plus 1 times f of 3. Plus 1 times f of 4. And then I am done. Those are my 4 rectangles I want to add up. So that means I want to plug 1 into my function, then 2 into my function, and so on. So my lower sum is going to be 1 times 1 squared is 1, plus 1 times 2 squared is 4, plus 1 times 3 squared is 9, plus 1 times 4 squared is 16. Again, 1 times anything is itself. So that gives me the lower sum is 1 plus 4 plus 9 plus 16, which gives me a total of 30. That is my lower sum. So looking at these two, my lower sum is 30 and my upper sum is 54. So my actual area will fall somewhere between those two. On the next video, you will get the mid sum, which might be a little bit more accurate. We'll go over that in just a minute.